Everyone, welcome back to my channel. Today's video is an extension to my part 1 video on attention mechanism, where I will introduce you to the concept of multi-head attention. The one which we had covered previously was the self-attention mechanism, right? Which is able to understand the interaction, the relationship between each of the words in any sentence on a broader level. But for a model to be an advanced to understand the advanced form of any sentence, to understand any complex sentence, it needs to understand the nuances, the subtle meaning of any text in a more intelligent way. And that's where the multi-head attention comes. So before I deep dive into what exactly is the multi-head attention, let's recall what we had explored previously. So we explored this groundbreaking paper, Attention is All You Need, which has become the revolutionary paper in the world of large language models, because it introduced us to the transformer architecture and the concept of attention mechanism. That is the core principle behind working of any large language models, right? Because as I mentioned, it enables the model to understand any input sentence, right, to generate any output, right? We also deep dived into this concept of attention using a real life analogy, where I explained the entire flow, how the input matrix, how a batch of 6 students, which comes with their own characteristics, own individuality, interacts with each other, and they form an attention matrix, and eventually their individual characteristics based on their interaction gets transformed into the revised characteristics, right? Now we will see how mathematically this entire mechanism works, in eventually to understand how the multi-head attention works, right? Now, before I proceed further for the multi-head attention and even the mathematical concepts, let me again reiterate the entire mechanism which you are seeing is the self-attention mechanism. Let me write it for you so to help you understand. Because every word is interacting with each other, every individual is interacting with each other on a broader level, right? And that's why it's the self-attention mechanism. But there are many hidden meanings. Even the same word has a different meaning when used in different context. Every word position, the parts of different parts of speech, all these every sentence has such kind of complexities, such kind of nuances hidden, right? And to understand those nuances, multi-head attention comes into the picture, right? Now let's start with understanding the mathematical concepts behind this entire mechanism, right? So the matrix which we are seeing here, the input matrix, let's use it with the name of Q is nothing but it's the query matrix, right? So I have considered those individuals mapped to 7 parameters, let's say, with certain values, right, based on their interest correspondingly, right? Now they interact with each other and their values are correspondingly calculated. So how we do this by calculating a dot product between the query matrix and its corresponding transpose. So let's name it with KT. So K is nothing but the key matrix, and KT is equivalent to query only. So KT is equivalent to QT. So we calculate dot product between both the matrices, and we divide it by the square root of number of parameters, right? And finally, we use a software function to the resultant values. So what software function does, it applies an exponential function to each of the value that we get from this calculation, and it normalizes in such a way that converts those values into probabilities that add up to 1. So as you can see, every row, each row, basically all these interaction, the scores are in such a way that it is the resultant sum is equivalent to 1, right? So it gives a relative comparison of which interaction are the most, which interaction is the most, is the best interaction, or which has the least interaction, which is the least mismatch between the properties, right? So this is the first step in the entire mechanism. This formula has been taken from the Attention is All You Need reference paper, and that's what I have used here. Now, the last step is to get the transform matrix, right? So the attention matrix which we had calculated from the previous step is then again multiplied with the matrix V, which is the value matrix, and is equivalent to the query matrix, right? So we are basically again calculate dot product between the matrix R and matrix V in order to get the transform matrix, right? So notice that the input matrix has the same dimensions as that of transform matrix, right? So basically the individual characteristics which every individual had gets transformed into the revised characteristics based on the interactions, right? So this entire mechanism is what the self attention mechanism flow, right, where every individual is interacting with every other individual on a broader level, right? Now let's come to reality. What exactly happens? So just like how we mapped those six individuals corresponding to different aspirations, different parameters of different interest parameters. Similarly, every input word, or better to say token, in the large language model is mapped to certain parameters in the similar way, right? So for example, I have taken six words. See, she saw a bat in cave, and mapped to some seven parameters. So F stands for feature one, feature two, feature three. So this could be anything. So feature one could be, let's say, noun. Feature two could be, let's say, name of the place. Feature three could be, any other parts of speech, and so on, right? So every word is, mapped to these features corresponding to their properties, right? So you can see this is of the format of 6x7 matrix, right? Now, the real world is not that simple, and seven parameters is not enough to map any model, to map any input word, right? And that's why we take several hundreds of features, or even thousands of features, right? For this video purpose, I have taken the parameters of 512 because it was taken in the attention is all you need reference paper. But don't get confused, it could be anything what we define in the model. Also, one thing I would want to add here. So the way we have represented this sentence, every word mapped to different parameters, different features. So you can consider these are the dimensions, right? So this entire concept of getting the words or tokens mapped to these features is the concept of embedding, and it's one of the very critical concept in the world of large language models, and I will also cover it in one of my upcoming video. Embedding, right? So basically every word is in the form of a vector, right, where it is embedded into a high dimensional space, such as in considering this scenario, it is embedded in 7 dimension space, right? So you visualize it in that way only, right? So this is the concept of embedding, and don't worry about it for now. Just consider this with the help of real life analogy that we had studied, how those individuals are mapped to these parameters, because I will cover this concept of embedding in details in my upcoming video. Okay. Right. So we were talking on the let's say 512 dimensions we are taking. So this will be in the form of 6x512, right? Now here is an interesting catch. So to understand, in order to understand the nuances of any input sentence, what does model do? So model basically splits this 6x512 matrix into smaller matrices called as heads, right? And each head will contain just few of the parameters from 512, right? So for example, this 6x512, I have split into 8 smaller matrices, which are called 8 heads. So this will be equivalent to 8 heads. 8 heads, right? And each head will have the dimension of 6x64. It can be anything. I mean, it can be even 4 small heads also, which will be of dimension. Each will have dimension 6x, I guess it's 128. Yes, it's 128. So there will be 4 such small heads, right? So the point is each head. So I mean, in the diagram, I have considered only 4 heads, but you can imagine. I mean, there for the for the pictorial representation, for the lack of space, there will be 4 more such heads. So there will be 8 such heads of 6x64 dimensions, right? So why we are doing this? Because every head will do the entire mechanism of attention, will interact with every other word properties, but see only some smaller part of the embedding of each word, right? So each head will focus on, let's say, each word will. So if I'm taking an example of, she saw a bat in the cave. So one head might focus on, understanding the subject verb relationship, like she saw, right? Another head might consider the, other relationship, let's say noun object connection, like bat in the cave. So, and even some other heads will also catch the other kind of relationship. For example, in one of the head, it will be able to understand the bat which has multiple meanings of, let's say, cricket bat, or let's say it is of any animal, or it is kind of animal. So each head will be able to understand, okay, the potential relationship, the potential meaning, and henceforth the context of the entire sentence, right? So it is able to understand the hidden meaning, or not, if not hidden meaning, the nuances of every sentence, right? So visually, if I again represent it in a better manner, this will how it will look like. So the matrix, input matrix, which is of 6 cross 5 12, it is there is a calculation that this, it is multiplied with the weight matrix. Now I will also explain you what does this weight matrix exactly is. So weight matrix are like the neurons of a model, right? Which are initialized with some random values initially, but gets revised with the right values during the training phase, which model has to undergo through. So whatever values you see here in the in every corresponding to all these dimensions. So basically, all these values comes from the weight matrix only, right? Then once the dot product between weight matrix and input matrix is calculated, it is split into smaller heads as we saw previously, right? So the entire mechanism of having 6 cross 7 and then 6 cross 6 and then 6 cross 7, it will look something like this, where we will have smaller matrices interacting with every other smaller matrices, right? So if I again visualize it in a better manner, so this will how it will look like. So we have the input matrix. It gets split into key, query, and value. Every individual key, query, value will be will be multiplied with its weight matrix, and the resultant matrix will get split into several smaller heads, as you see here. So there will, since I have considered 8 smaller heads, so that's why I have drawn out the 8 heads, right? Please note that this image I have taken from one of my favorite YouTuber Umar Jamil, and so yeah, that's where I have taken this image. Now you can see each. Since you can see here all these smaller heads. Now note that every small heads will interact with every other smaller heads in order to form the transformed matrix, which is heads, which is in the green mention. So basically, these are the transform matrix, but these are in the split form. So this will be T1, this will be T2, and so on, right? So every as we saw as a first step, where we calculate the attention matrix, and then we saw the second step where we calculated the transform matrix, right? This is a step 1, this is a step 2. So here, for example, Q8 will interact with K8. The dot product is calculated and we divide it by the square root of number of parameters, and then we apply the sorter function. So the resultant attention matrix will again interact with the V8 to form the T8 matrix, right? So similarly, every other matrix will have such self attention mechanism calculated in parallel, right? So eventually this will get concatenated to form the multi-head attention matrix, right? So we can say the multi-head attention extends the concept of attention by employing multiple self-attention mechanisms in parallel. So instead of relying on a single perspective to understand the relationship between words, it will allow multi-head attention allows the model to consider various viewpoints simultaneously. And this is how the model is able to have the conclusive interaction for a complete context, right? So I hope you were able to follow me through. And if you have any question related to multi-head attention, feel free to drop them in the comments and I will try to answer them as much as possible. So thank you. And if you have liked this video, please do follow me and subscribe to my channel. Thank you.